Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's dive into today's daily challenge on Leetcode and try to break it down together. So the problem is total characters in string after transformations 2. So it's the second version of the problem for yesterday. And you in this question you are given a string S consisting of lowercase English letters and an integer t representing the number of transformations to perform, and an array of nums size 26, and you need to perform exactly t transformations. Each Si would be replaced by the next nums Si minus a. So it means that if there is a and the number corresponding to the a, the mapping corresponding to the a in this array is 3, then it will be replaced, a will be replaced by the next three digits, next three alphabets of a, that is b, c and d. And this transformation wraps around itself. It means that if there is z, the next characters of z would be considered a, b, c and so on in a circular manner. So if the s of I is y and still the nums of 24, like I mean the second last element in the nums is 3, then it will transform to y of 3 characters after y, which is z, a and b. So this is the thing we need to do, and we need to return the length exactly after 3 transformations. So here, what are the exact transformations to perform at each step it is given. Now if you see in this problem, uh, a becomes b since nums is 1 and only one character is there. But in the z, the z would after like t equal to 2, the nums 25 is 2, so z will become abs, and hence the length will increase by 7. So if you see the constraints are quite high. You cannot perform the in linear time as you were doing in the last day's problem. Like you cannot simulate the transformation, and also you have a nums array according to which the transformation should be done. So if you believe this problem is actually much easier than it seems. How can I say so? So let's just try to understand what can be the possible approach for this. So let's just try to start. You have some array. So if you have some string, let's say a, b, x, y, z, and let's say c, d, something like this, and let's say again a, b. So this you can store it in a frequency array. You can store it in a frequency array of I. You can create a frequency array. Now you need to update the frequency array, right? Also you know that this frequency array of will undergo some transformation t. This transformation, how to perform this transformation is already given in the form of nums array, right? In the forms of nums array, the how to perform this transformation is given. Then you get some frequency dash I. So what you need to do is you need to perform this operation transformation t, small t number of times. So all you need to do is, let's say you have a frequency array, then you perform a single time transformation to get some frequency. So you just need to tell that if you want to perform it t times, what will be the transformation. Okay, so this is the thing which you need to do, and this is the final answer of the frequency array. And you need to sum the I am exactly telling what kind of transformation, how will we visualize the transformation in detail, I will tell you. But overview you should get easily that this is quite simple, right? One transformation, if we get it one time, so we need to just perform t transformations and then output the final answer. This will not be the answer. There's the sum of all elements of I from I equals to 1 to 26, the frequency. So that will be our answer. Definitely we need to perform a modulo. Okay, so I think you get the overview of this at least. Now let's see how does this transformation t exactly happens. So let's just try to find it out. So yeah, now you see, let you have some frequency, right? You want to update it by some transformation matrix. Okay, and you want to get a new frequency you want to get it. So you have some initial frequency. Now you want to tell that let each element of this t be tij. You want to say that when I am expanding I, when I am expanding the character I, now I want to expand the character I j times. If I am expanding the character I j times, what will be the change in the I? Okay, so what I am telling you, that if you want to expand this C, if you want to expand this C, let's say C, after C there is some 25. So after C, like from D you need to start D, E, F, everything you need to write. You may also get an A, okay, after at the end. Similarly, if you start with M, N, something like this, you will also get an A. So from C or from M, N, from anything you can get an increment in frequency of A. So this tracks in increment in frequency of all the 26 characters, right? So for A, so if you are expanding the character I, if you are expanding the character I, that is here I represent, let's say C, what are the changes you get in A? What are the changes you get in A? Like, do you get an increment? Do you get A plus plus? Do you get the frequency of A plus plus, or do you not get it? This is our question. So you can easily understand the transformation, right? So this way you can track the frequency. So you can take each of the character and tell that whether each of them have some transformations on every other character. So in this way you are tracking the frequency of every other character, right? If you did not understand this, try to just replay this portion again and mark each of my word as I say it, because this is really important, and I think it's quite easy to get it. I mean, if you are just expanding C, I just took an example, if you are expanding C j times, that is 25 times or something, will you get A? Will I get A? Whether I need to increase the frequency of A or not, that is given by our transformation. And if you see for every iteration, this transformation is independent of the ith iteration which I perform. So I can just multiply this matrix 3 times, and to perform this 3 times I will use binary exponentiation. So what is that also I will explain in detail, no need to worry about that. So I think this so as I code I will keep on explaining, no problem with that. So this much you should understand, that the overall workflow of the problem. Okay, so let's just try to start coding. I also need to return to the whiteboard again to explain you many other things. So let's just try to start at first and actually see this problem is going to be really easy. So if I have some global variable, let's say mod, which will be 1e9 plus 7, I also need to has define long. Okay, so if you see, we'll try to keep things as much simple as possible. So what did I say? At first we need to return the length of the string. We need to take care of the length of the string for the iteration. So at first what I need to tell you, I need to keep a frequency array, frequency map of arrays, which will be 26, and it will be initialized with zeros. Also I will iterate from 0 to n throughout the string and update our frequency array accordingly. You get it, right? Update the frequency array accordingly. Now I have the frequency array ready with me. Now I need to apply transformations over this array. Okay, and then multiply the final values. So what I need to do is I need to transform it. So how can I transform it? Let's say I keep the auto variable. I have a transformation matrix. So how will I design the transformation matrix? So as I told you, transformation matrix Tij shows that what will happen if I expand while expanding I j times. So that is I plus j, right? We get I plus j. Then it is also told that the transformation wraps around itself. So I cannot just blindly add j. I need to do a modulo 26. So to take care of that, it wraps around itself. So it's very simple. The transformation will be a 26 cross 26 vector, or definitely the transformation T I have 26, and the vector integer I have 26 cross 0. So if I go through it I times, I cross j times, j less than 26, j plus plus. If you see it, uh, what will be Tij will be equal to Ti I plus j modulo 26. Isn't this true? Tij value I am updating whether this is true or not. So this will be just plus plus. So this is plus equals to 1. So whether, so after expanding I j times, I need to change whether the frequency of I will get changed or not. If it gets changed, if it is affected by I, then I do a plus plus value. Okay, this is everything. So now I need to also perform, let's say, auto t to the power t. Let's say I'm representing it by this, and binary power, the function we will define later. Binary power tt. Okay, and what I will need to do is that I will need to do the final frequency. So frequency vector, updated frequency vector we need to take care of. Updated frequency vector, we let's say have it 26 0. So yeah, uh, what I need to do is perform a matrix multiplication of this updated frequency vector. So if you see how to perform a matrix multiplication when this is a single value and this is an I cross j value. So for every I, okay, for every row, the value will be this whole multiplied by this all. So for all the j's, this is I, this value is I and this value is j, right? So I will do a double for loop, and for all the j's I will just multiply with the corresponding value of f of I. So for all the j's of a particular I of t, I will multiply with all the f of I. So I just do a loop. Okay, so I will just say that if frequency of I is 0, if frequency of I is 0, then we will just continue. No need to do anything. Otherwise, updated frequency, we do have an updated frequency. Updated frequency of I plus equals to what did I tell you here? Uh, this ij will be multiplied with I. So you see ttij will be multiplied with fq of I. Okay, so to give a mod here, I will just keep this mod as well as perform another mod. Okay, and at the end I will store an answer value, and I will traverse through the updated frequency array, and I need to give the sum of all the frequency, right? You have updated frequency of I modulo mod, and you will just return int of answer. We'll just type cut this LL into int since the output is in. So yeah, we have this. Now we need to write the binary power. Now how to perform this in an optimal way? Do we need to physically multiply? So I will also explain you the concept of binary power. So this is nothing but vector of int, which is taken by the binary power because it returns a matrix. And input also we have one vector of int, which is the t, and we have an exponentiation value. Okay. So how I will perform this t to the power exponent function? I will keep a result array. I will keep a result array of size 26 cross 26. Okay. So let's try to understand binary exponentiation quickly. So first I am telling you that what we will do with numbers, simple numbers, and then how can we expand binary exponentiation with matrix. So if I want to perform let's say a to the power b where b is very large, for instance let's take b is 10. What can you do? Iterate a 10 times, okay, but that will be take o of 10 time, but that is undesirable, right? We want to shorten it. This is the binary. The word binary means we focus on the binary representation of 10, which is let's say 1010, right? You can understand this, which is 2 to the power 1 plus 2 to the power 2. So you can understand that if we can multiply somehow a square, the result is 2 and the result is 8 here, a square into a8, we will get a to the power 10. So what we will do is that instead of multiplying 10 times, we will traverse through each of the bits of 10. We will traverse through the bits of 10 and check if it is 0 or 1 and accordingly do it. Okay. We will keep some result 1. Let's say the initial result is 1. Every time for every bit we will do a will be go to a square, then go to a power 4. This is for let's say bit 0, bit 1, bit 2. Bits are in the order of this, bit 3. Okay, we have a power 8. So what we will do that we will keep multiplying a with a square. And how we will get this? This a power 4 can be easily got by multiplying a square 2 times. No need to do it 4 times, right? A power 8 can also be multiplied just the previous value with 2 times. So that can easily be got. So I'm just squaring it every time and storing the values. So whenever I get a 1, so here I get 1, I get where I get 1 in the places of 1 and 3, right? In the places of 1 and 3 I get a 1. In places of 1 and 3 I take those values and multiply into a result. So when I am getting 0, I will not do anything to my answer. When I am getting 1, I will multiply my answer by a square. When I am getting again 2, I will do nothing to my answer. When I am getting 3, I will again multiply with a power 8 to get a power 10. So this is how binary exponentiation works. If you see the result starts with 1, so in case of matrix, suppose A is a matrix and I need to perform a power b, then this has to be a matrix of this type, identity matrix, right? This has to be an identity matrix, and this these things will be taken care of matrix multiplication, which we can define easily. Those functions we can define easily, right? So let's just see how will that work. Binary exponentiation. So I have the result ready with me. I need to initialize the result as an identity matrix. So I have the j0 to j less than 26, j plus plus. So I don't need to do anything so much. Only the values in the denominator I need to change it. So result of I will be equal to 1. So this is the initial thing. So how till what time I need to do the binary exponentiation? While exponent is greater than 0. Okay. So what I will do, I will just store my exponent value. Suppose I have the exponent value 10. I will do the binary representation. Binary representation is easily taken care of. I will bit right shift it. In one step, I will just check. I will right shift it by 1, then again right shift it by 1, and then again right shift it by 1. So I will right shift the bits so the rightmost bit will be toppled off, and till it is 0 I will keep on performing this so that we can easily get access to the last element of the bit, right? So this is how we do it. So while exponentiation is greater than 0, and you need to check if it is odd, the exponent and 1. This means if it is odd, what will I do? I will just multiply with the result, right? I will say that result is equals to matrix multiplication of result into the transformation T matrix. And every time I need to do t square. This I told you that every time I need to do a square, I need to square it. So for every time I will also square it. So t will be equal to matrix multiplication of t into t. I will define this matrix multiplication function, and all I need to do is return result. So yeah, that is fine with the matrix multiplication and stuff. So just check it once more while exponent is greater than 0, and also you need to right shift in every iteration, right? So you need to right shift it by 1. Okay. So in every iteration you are just exponents equals to exponent right shift 1. That you are doing. While it is greater than 1, and if it is odd, that is if I get a bit 1, then I will result multiply by the result. If I don't get a bit 1, then I don't do anything, and in every iteration I just keep increasing the transformation matrix, and this way we get a binary power here. Now all we need to do is to define this matrix multiplication function, which I think is going to be very easy for you. So I have this matrix. If I will explain this also about how it is happening. So we have two vectors here, right? We have two vectors. Let's say we have vector A and we have vector B, and we need to get a resulting vector, this result. So this value I have again. So A result is equals to A multiplied by B. Now if you see in the matrix multiplication what happens, I told you how does matrix multiplication happens when there is a linear vector and a full matrix. But what if there is a full matrix again? So if you just see how I will just find it. So you see each element here is ijk, ij, let's say aij, and let's say this row is going to multiply it with this row. So you see for every I, this is I, this is j, right? For every I what you are doing, you are traversing through j and multiplying it by a jk, right? So this iteration has to be, so distance from this has to be distance from this, right? So if this value is j, then this value is to be j, has to be j9 now, and this is a square matrix, we are multiplying it. So yeah, that's how that works. So ijk, so this is not b, this is bjk, so aij must be multiplied with bjk, okay, in order to get our result ik. This is, so all we need to do is a triple for loop. So let's just quickly write the triple for loop. J less than 26, j plus plus, or int k equal to 0, k less than 26, k plus plus. Let's store something like aij is nothing but, what is this? It's nothing but aij, right? Yeah, it's as simple as that. If aij is 0, we just continue it. We don't need to do anything, right? Already we have 0 then, and all the initial values are initialized by 0 only. So now what we do is get the result ij equals, so what I told, result ik equals to aij bjk. Result ik will be equal to result ik plus a ij, I have aij, and bjk. So let's not forget the mod, otherwise there would be a problem. Okay, let's just not forget things out and return result. So you see, if you know the binary exponentiation, if you know matrix multiplication, the code is just this much. It's nothing much. Okay, so I think this should get the correct answer. If I have not done anything wrong in between, let's try to run it. Okay, so we are getting the wrong answer. We definitely have some implementation issues, logic. Okay, so if you see that I have done here j equal to 0 to 26, but what is j? I need to expand j nums times, right? So j is nothing but nums of I. J goes from 1 to nums of I, because nums of I tell that how many times you need to expand I. So how many times you need to expand I is j, because we are adding I to j, to that value, and check and just incrementing that frequency, right? So we need to increment j from 1 to nums I. So let's try to submit this. We have this accepted. Let's try to see it if it works for all cases. So yeah, we do have the accepted thing. You can see it's very fast because of the binary exponentiation and this bitwise operations which I performed. So yeah, that was all for this problem. This was a hard kind of problem of Leetcode, but the logic is really similar. This is difficult because you need to implement the binary exponentiation and implement the matrix multiplications and stuff like that. So yeah, that was all for this problem. Although these problems may seem hard to you, I think it's easy now, and I hope your day is going to be really easy too. Thank you so much.